Yes, and I'm trying to get you guys in the habit of doing that because what'll happen here eventually is that when we get to triangles, about next weekish, you're going to be given multiple things to start with. So what'll happen is, let's say you wrote both those two given statements down right off the bat, but you'll forget to do something with one. That's really, really, really common. So by separating your givens, you write one of them down, see if there's anything to say about it. In this case, we had a definition for the bisectors. And then we went to the next statement. You do that each and every time to help keep things straight. Okay? Ready for some angle stuff? Well, we're going to do some angle stuff. We got progressions. Progressions! Aren't you excited? Which one are you going to start with? All right. Angle bisector. What do you think they do? Okay. When you have an angle bisector, what do you think occurs? All right, guys, here we go. Angle bisector. Yep.
Alright, so you guys just did segment bisector, so now it's angle bisector. So these, if you're given an angle bisector, so what are you gonna be able to say from that then? So with segments, you're gonna segment bisector, then you said the segment was congruent to the segment. Yep, so now you're gonna state that the angle is congruent to the angle. Right? So then your example here, if you're given that segment BC or bisects angle ABD. Does this roll up though?
Actually, I think you might have bumped the what do you call it?
It's giving me a bunch of squares.
Yeah, hit the arrow button, the pointer.
This?
Yeah.
And then it should be?
Now your scroll,
Nope,
your scroll got switched to the side. There you go. If you hit the, see there's a.
Probably erase these.
No, those you have to actually do something with.
Alright, the squares aren't part of it. Alright, does everyone have that down? Alright, so what would be your given then? Yep, so you're going to write that given then as your first step. So you, oh god. This? Here? Thank you. So BC bisects angle ABD. And that's your given. So then using that given, your statement would then be that angle ABC is congruent to angle CBD. Huh? In what? This? Yeah, that says AB. Yeah, it got a little squished. It just is rewriting that given statement there.
And that's the downfall with angle stuff, guys. There's so many letters to it, it can get kind of messy. The procedures and everything that we've done with segments, they're all the same. It's just more letters. And that's where if you have substandard handwriting, it can kind of be a hindrance, shall we say.
So if given angle bisectors, then that statement that you're going to make is that those two angles being bisected are congruent. Reasoning is definition. You can ask me a question.
No, it's not on that.
Okay.
I already told you you were dumb asking questions. I said I knew you were.
Definition of angle bisectors. Okay, so now if I want to make a new one, does everyone have this down? You guys can move on to the next one? No? Alright, let's see if I can do it. Yep, new box. Little victories. Alright, so now if you're given supplementary angles,
Think about the stuff that we've been doing in class, guys. A lot of the stuff that we've been working on is basic algebra. Adding, subtracting. A lot of times with angle pair stuff, we kind of use this as well with some very simple algebra. So that's why we're bringing back in supplementary and complementary here in a minute and stuff like that. So that way we can continue doing proofs with algebra before we get into the crazy stuff.
so you haven't worked with supplementary before. What does supplementary mean? How many degrees?
180.
Yeah. So if given supplementary angles, then what your statement is going to be is that then your two angles should add up to 180 degrees. So that makes sense. Just remember supplementary goes with 180. I'm sure Mr. Murphy's given you some trick to try to keep supplementary and complementary safe. I know I use alphabetical what comes first or what number comes first. Works well for me. So then your example, so your given would be that angle A and angle B are supplementary. And then in your proof, you would again write down that given statement, angle A and angle B are supplementary. Reasoning for that given. Yeah. Yes. Yeah. I guess my angle signs. Oh, yeah, that's an and symbol. So what can you conclude given that given statement then? Look back at the statement here. Yeah, so now you have these two angles, angle A and angle B. So your conclusion then based on that given would be that angle A plus angle B add together to be 180 degrees. So you write angle A plus angle B is equal to 180 degrees, and that's definition of supplementary. Definition of supplementary. Does everyone have all that down? Still going? Alright, so next we have linear pairs. You guys remember working with linear pairs? Yes. Hopefully you don't revisit them now. So kind of very similar to supplementary angles. If you're given a linear pair, you can state that, again, the angles add to 180 degrees. Oh, wait.
How would you know? That's how. No, no.
That's a good question. How did you guys know?
Or, so if, well, go back a second. You're saying, how would you know which one to use? If you're using a linear pair or supplementary? Or the fact you might just literally say if they're linear pair
Yeah.
or supplementary?
So whenever we have those given statements and the given are saying this angle, or supplementary, then you're going to use definition of supplementary because it wouldn't make any sense. to go with a linear pair.
Yeah. It becomes very, very difficult.
So then, example here, just like you were saying,
Guys,
so your problem would say angle x and sine angle y are a linear pair. So here you know you want to use the linear pair. It's not telling you that they're supplementary. It's telling you that you have a linear pair. So step one then, write down that given statement, angle x and angle y are linear. Start with the given, and then what can you state from that given? What can you say about angle x and angle y, given that you know it's a linear pair? Yeah. So they don't both equal 180, but they add together to equal 180, so you don't know that. So then you can say angle x, when added to angle y, is going to give you 180. And then that's your definition. Of a linear pair. Yeah. Yep, because you're going to look at your given statement and it's either going to say angle x and angle y are supplementary, or angle x and angle y are a linear pair. So then just use the definition that goes with that one. And I don't think that you would be given both in one.
No, and we try to, it's, the reason, like, we keep saying that the reason we use these progression sheets is because they are very literal. You know, you are given specific information, you use that given specific information to finish the problem. That's why we try to cover all bases.
All right, next one. Everyone have this down before we move on? That's good? So the next one then, so going along with supplementary then is complementary. So if given complementary angles, now you guys have already said it. How many degrees are there if they're complementary? Huh? How many degrees in complementary? You guys too busy writing? 90, there you go. So again, use the alphabet. Complementary comes before supplementary, C before S. 90 is smaller than 180. So if given complementary angles, then you can state that angle plus angle is equal to 90 degrees this time. So then problem would look like angle C and angle D are complementary. I made another square again somehow. I'm still writing, but it just made a square.
What happens is you when you click to the pen parts,
Uh-huh.
if you click to the pointer above that,
Uh-huh.
you won't open anything up.
So you
Yeah. 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 So now no matter what, all you have to do is change color here, the tray. Is the same. And now you don't have to worry about it. If you touch it with your elbow or anything like that, the square's not back.
because now I have both selected.
Right.
Okay.
Yeah. It's one of those weird things.
So then you're going to write down that given statement. First step, reasoning is given. Should be getting the hang of doing that. And then what statement can you make with that given? Huh? Yep, so angle C plus angle D equals 90. And then your reasoning is definition of complementary angles. Make sure you keep it straight. Supplementary 180, supplementary 90. There you go. Just two more. But they're fast and they're easy and they're things that you guys know. It's just how do you take what you know and put it into groups. All right, does everybody have this down? It's good?
Hey, remember today also is going to be a really, really good day to make sure you take a picture. Yeah, you take a picture of the progression sheet in case you lose it. And we got a hard backup digital copy of it.
Guys, what does this symbol mean? Perpendicular, good. So if given perpendicular, then your statement will be right angles formed. And then this one's a little bit trickier because then you have a second statement after that. Then you can state that right angles are congruent to right angles, because you guys know that when you're given a perpendicular, the perpendicular makes right angles. So then you know you have two right angles there, so those two right angles are going to be congruent.
Perpendicular ones take a minute or two to go through because you can't just jump steps. We were talking about a lot of times with proofs, you have to be very literal with everything. You can't just say something happened without saying something happened prior to it. That's why we have to go through all of these. My hand is back. At one. Come on, my handwriting's awesome.
All right, so then the problems that you're going to get would look like this. So tell you x, y is perpendicular to AB at point y. So in the diagram here, that's telling you that this segment XY is perpendicular to this segment at point Y. So now you know that here's your two right angles that have been formed. So then you're going to use your two-column proof, rewrite that given statement. So XY perpendicular to AB at point Y, that's given. So then remember here you have two statements that you're going to make from that given. So the first statement, what would it be? Yep. So then you can say, you don't have to just say right angle and right angle, you could label what those right angles are called. So here it would be angle A, Y, X, and angle BY, X are right angles. No. All right, accidental square there again. And that's definition of perpendicular. See, but I would have the things split. I'm just really gonna make this split. And then your second statement then is then you can say that those two angles are congruent to each other. So you can say angle A, Y, X is congruent to angle B, Y, X. Because you know that all right angles are congruent. So like Mr. Murphy said, right angles are a little bit trickier because you have to take two statements from the one given. But all things that you guys know, it's just how to write them in the proof.
And the sheets can be hard because there's no reason for you to ever freak out.
Yeah, so make sure you guys get this down now, because then it'll help you later. Only one more today. You guys have one more box.
What's that? You know, I forgot to bring it home. I apologize. I'm gonna finish that today. I'm sorry. Like I said yesterday, I made a mistake on the answer key, and I was gonna bring it home, and I forgot to bring it home. You could have, but yeah. I'm sorry. It's my fault. They're not bad. I just forgot to fix them. I literally just forgot that.
Last one. It goes right along with the one you just did, so. So now you're not given perpendicular, but you're given right angles straight away. So if you're given that you have right angles, your statement, just like how we did in perpendicular, so then you can say that those right angles are congruent to each other, because we know that right angles measure 90 degrees. So if you're given a problem and it states that angle 1 and angle 2 are right angles, so it's going to look like they're perpendicular, but they're not giving it to you that it's labeled, but they're telling you that really it would have those little boxes that you guys should recognize drawn in there. Then how you're going to want to make it look in the proof is you're going to, again, write that given statement, state that it's given. So angle 1 and angle 2 are right angles given. So then your statement, look back up here, your statement's going to be that angle 1 is congruent to angle 2. Reasoning, all right angles are congruent.
See one in action now, how this works? All right, let's do a proof. Let's use what we just did. Let's do a proof. All right. For example. So I know we don't have all that much time, but with the information that Ms. Yule just gave you guys, we should now be able to get into fairly simple angle proofs, whether they are complementary, supplementary, perpendicular. A lot of the things, remember you have to, when we're looking at them, is that you only know how to do certain things. Just like with segments, you only knew midpoints and segment addition. Well, angles, you know angle addition, two smaller add up to equal to larger. You know angle bisectors, cuts it in two equal parts. And then you knew some of the angle pair relationships, complementary, supplementary, linear pair, perpendicular. And now all that's down on paper, so we can start to going through what info do you have in front of you to solve it out. Okay. So in this one, what is the first given statement? Angle 3 and angle 2 are complementary. So how do you start your proof? You're putting that down, right? Angle 3 and angle 2 are complementary. All right. On your progression sheet, you guys just wrote out what to do if given complementary. What do you say? They both add to 90. So what two angles add to 90? So I would write angle 3 plus angle 2 equals 90. What's my reason? Perfect. Definition of complementary. You're using the progression sheet that's right in front of you. Is there anything else I can take from that information? No. Remember, the progression sheet tells you what to do and when. Once you've stated the two angles that add up to equal 90, you've used up all the information from that progression. You've gone through it. Is there another given statement then? Yeah, what is it? All right, angle 1 plus angle 2 equals 90. Okay? Now you want to prove something about 3 and 1. You want to prove something about 3 and 1, so what do we have to do? What do we do? Careful. Do you have two things that equal the same thing? What are they both equal? So they have to equal each other. What did you do? Good. I know we're writing really short here. What would you have to do now? What would you do? How do you do that? Subtraction. And then you have angle 3 equals angle 1. Then what do you do to show them that? What I posted on the calendar, we're gonna stay away from this sheet for today. I found 2 other different proofs of angle stuff. It's on the calendar. There's 2 proofs, fill in the blank style. I would just recommend just rewriting it with the picture and just do that on a separate sheet, okay? There's just 2 of them on the calendar. It's a PDF file. Pop it up, screenshot it now, and we'll get back to this packet stuff tomorrow, okay? We didn't get into many of them. I thought I'd just